Hello everyone, today we are going to discuss about spanning tree protocol. How do spanning tree protocol work? First, the root switch is selected. All ports on a root switch is put to the forwarding state. All non-root switches select the best path to reach the root switch. This port, which is the root port, is placed in the forwarding state. The switch with the best path to the root switch is placed in the forwarding state, and this is called the designated switch, and the port of this switch is called the designated port. All other ports are blocked. So I will discuss about forwarding state, root port, designated switch, and the blocking states in the upcoming slides. So before that, we will discuss about these steps in a network. So here we have three switches. First, the root switch is selected. So switch 1 becomes the root switch. So all ports on a root switch is placed to the forwarding state. So the ports of switch 1 are placed to the forwarding state, and all non-root switches select a root port. So then a designated port is chosen and all other ports are blocked. So the states and the ports. So what is forwarding state? This state is an ordinary state. It sends and receives traffic as usual. So what is a root port? This port is the best path to reach the root switch. Next is the designated port. As I've already told you, the switch with the best path to the root switch is the designated switch, and the port of this switch is called the designated port. Next is the non-designated port, the port which is blocked. Why there is a root switch? What is the purpose of a root switch? So if the root switch is not there, then we cannot select the root port and the designated port and also the blocking port, because we are choosing the root port and the designated port based on the cost to reach the root switch. So there must be a root switch. So how is a root switch elected? The root switch is elected by observing the bridge IDs. The bridge ID contains two fields. The first field is 2 bytes and it is the bridge priority, which is by default 32,768 plus the VLAN number. And the second field contains the MAC address of the switch, which is 6 bytes, and it is totally 8 bytes long. So now here we have an example network to explain how a root switch is selected. So here we have switch 1, switch 2 and switch 3. So first, switch 1 decides itself as the root switch, and switch 2 and switch 3 also will do the same. Now they will send this information to all switches in that network, which means switch 1 will send this information to switch 2 and switch 3, and switch 2 will send this information to switch 3 and switch 1. And switch 3 will send this information to switch 2 and switch 1. So now switch 3 decided itself as the root switch. But now when it received this information from switch 1, it sees that the BID of switch 1 is lower than itself, and also switch 2 is not lower than switch 1. So it decides that the switch 1 is the root switch, and switch 2 also will do the same. Now the root switch is elected, which is the switch 1. This is how the root switch is elected. So the command for changing the bridge priority. We can take control of the process of electing root switch by changing the bridge priority to a lower number by using the following command. Spanning tree VLAN 1 priority. So the priority can be any number, but it should be a multiple of 4096. So now let's open the Cisco packet tracer to have an example network and to change the command change the bridge priority in a switch. So here we have an example network with 3 switches. So let's go to switch 0 first and let's give enable. Here let's give show spanning tree. So here we have both the ports in the forwarding state and both are in the designated port, which means this is the root switch. So let's go to switch 1 and give the same command, which is show spanning tree. So here one port is the root port and other one is the designated port, and both are in the forwarding state. So let's go to switch 2. So let's give show spanning tree. So here one is the root port and other one is the alternate port, and one port is in the forwarding state and the other one is the blocking state. So alternate port is nothing but the blocking port, non-designated port. So now this is the root switch, which is the switch 0 is the root switch, and here we have a blocked port, which is the fast Ethernet 0/2 of switch 2. So here fast Ethernet 0/2 of switch 1 is the designated port. So now let's take control of the process of electing the root switch by making the root switch as switch 2. So for that, here you can see that the priority here is 32,769 because it is plus the VLAN number, which is by default 1. So now let's change it to 4096. So let's give config terminal. Yeah, now let's give spanning tree VLAN 1 and the priority has 4096. So now let's give show spanning tree. So here you can see that the priority is 4097 because it is plus the VLAN number, and the port of switch 2 fast Ethernet 0/2 is in the listening state, which means it can only listen the traffic and it cannot forward anything. So now it will be it is changed because because both are in the forwarding state now and both are the designated port, then this is the root switch. So now the port of switch 1 is blocked, the port fast Ethernet 0/1 is blocked. So now let's try another command. So let's give config terminal. Now let's give spanning tree VLAN 1 and the priority has 4097. This cannot be accepted because the allowed values are 0, 4096 and the multiples of 4096. So only the multiples of 4096 are allowed. So if we give 4097 also, it is not accepted. So now we can see that switch 2 is the root switch and we have changed it. So now let's try making switch 1 as the root switch by giving the bridge priority as 0. So now let's give spanning tree VLAN 1 and the priority has 0. So here now let's give show spanning tree. So one port is in the listening state and the other one is in the forwarding state, and both are the designated port. And now the priority is 1 because the VLAN number is 1. 0 plus 1 equal to 1. So now here the port is blocked only, but is actually listening. Now it has changed, which means both are in the forwarding state and both are in the designated port also. So now this is the root switch, and one port is blocked, which is the fast Ethernet 0/2 of switch 0. So now let's discuss how a root port is chosen. Now, how is a root port elected? The root port is elected by seeing the cost. The port with the least cost to reach the root switch will become the root port. So let's have an example network. So here we have 3 switches and the root switch is switch 1. So both are in the forwarding state. The ports of switch 1 are in the forwarding state, and switch 1 sends an information to switch 2 and switch 3. It sends that the cost is 0 to reach the root switch because it is the root switch and it has the cost has 0 to reach itself. So now when switch 2 and switch 3 receive this information, they calculate that the cost to reach switch 1 from switch 2 is 4, and the cost to reach the root switch from switch 1 is 0. So 4 plus 0 equal to 4. And switch 3 also will do the same. Now they send this information to each other that the cost is 4 to reach the root switch. Now they calculate that the cost to reach from switch 2 to switch 3 is 4, and the cost to reach the root switch from switch 3 is 4. So 4 plus 4 equal to 8. So both the switches calculated, and now the cost is less. Which is 4 to reach switch 1, and 8 is high. So this will become the root port. And this is how a root port is elected. So the next is how a designated port is chosen. The switch with the lowest cost to reach the root switch is chosen as the designated switch, and the port of this switch is elected as the designated port. If the cost dies, then the switch with the lowest bridge ID is chosen as the designated switch. So now let's have an example network. So here we have 3 switches. So the cost to reach switch 1, which is the root switch, from switch 2 is 2, and the cost to reach the root switch from switch 3 is 4. So now switch 2's port will become the designated port because it has the less cost to reach the root switch. But what if the cost dies? So now the bridge ID is seen. So here the bridge ID is low for switch 3 only. So the port of switch 3 will become the designated port. So this is how a designated port is chosen. So today we have discussed about how is a root switch elected, how to change the bridge priority, and how is a root port chosen, and how is a designated port chosen. So please subscribe my channel for more videos. Thank you.